Each year, the Louisiana Department of Transportation and Development conducts thousands of highway construction, expansion, and maintenance projects. These jobs often require analysis and characterization of the soils at the construction site. For many years, the department has maintained a large pool of sophisticated drilling equipment and staff to gather the necessary soil data. The conventional soil sampling procedure, which involves exploratory drilling and laboratory analysis, is an expensive, time-consuming, and often hazardous process. In fact, delays in starting critical projects have occurred as a result of long laboratory testing periods, which sometimes yield unreliable results. To make things worse, budget cutbacks have forced a reduction in personnel and equipment, causing soil sampling work to fall further behind schedule. Recognizing the need for a more rapid and accurate method of site characterization, LTRC, the Louisiana Transportation Research Center, has adopted cone penetration test technology for highway subgrade characterization. In 1989, LTRC successfully implemented this technology in a new mobile soil testing platform known as the Louisiana Electronic Cone Penetration System, or simply as the cone truck. Although it was a significant departure from the traditional exploratory drilling and laboratory analysis approach, it has proven to be a very successful method of determining physical properties of in-place soils. The increasingly popular cone penetration test, or CPT, essentially consists of pushing a specially designed electronic probe into the soil. The resulting CPT data produced by the probe can be used to determine not only the soil type, but other important soil properties as well. This same CPT technology was used in the development of a new continuous intrusion miniature cone penetrometer test system, or CIM-CPT. You can find this technology on the roads of Louisiana in a new mobile laboratory, which we call the Mini Cone Truck. This four-wheel drive vehicle contains all the necessary equipment to quickly perform on-site soil characterization tests. Compared to conventional methods of boring, sampling, and laboratory analysis, the CIM-CPT system is a reliable, economical, repeatable, and time-saving way to characterize soils at the job site. Although it is not able to penetrate to the same depths as its big brother, the cone truck, the Mini Cone Portable Lab has proven to be a valuable soil testing system with numerous applications. Operated by a minimal crew, which can be as small as one person, the vehicle is first positioned directly over the sample site, then secured in place using a hydraulic support system, which provides the leveling and reaction needed during cone penetration. With the cone guide tube appropriately leveled, the cone penetrometer is advanced into the ground using a hydraulic-powered continuous push device. The cone rod is actually a 1/2 inch diameter stainless steel tube that is uncoiled as the cone is advanced into the soil. This single-piece coiling thrust rod simplifies waterproofing of the cone electronics by eliminating threaded connections found on conventional CPT systems. The probe tip is equipped with an electronic load cell that measures resistance offered by the soil during intrusion. It is also equipped with a friction sleeve to measure the local friction between the surrounding soil and the shaft of the probe. As the cone penetrometer penetrates the subsurface, the continually changing electronic signals generated by the cone tip and friction sleeve are transmitted to special interface modules that convert analog input signals to digital information. A laptop computer is used for acquisition, processing, and analysis of the soil data. A global positioning system, also installed in the Mini Cone Truck, transfers test site location data directly to the computer. Within minutes of completing a test run, project engineers can be provided with an accurate soil characterization analysis. Delays associated with the older exploratory drill and sample method are significantly reduced. There are still other advantages to this new CPT system. The miniature cone penetrometer gives more detailed information when compared to the standard size cone, making it more attractive for subgrade characterization, compaction control testing, and assessment of ground improvement projects. Soil data obtained can be used in the design of foundations, piles, piers, and abutments supporting bridges. The system may be used to test beneath existing pavement through a 1-inch access hole, making it less intrusive than conventional boring methods. And to provide greater mobility and accessibility to remote sites, the CIM CPT system platform can also be mounted on off-road four-wheel drive vehicles. There is no doubt about it. The new mini cone truck is going to change the way soil characterization tests are conducted as part of Louisiana's transportation projects.
The continuous intrusion cone penetration system, I think, will be the system to use in the future because it's reliable, economical, repeatable, and certainly very fast. It uses minimum crew. It's very mobile. The system that we have also incorporates the global positioning system so that when the testing is done, you know the exact location where you are looking in the subsurface. From the viewpoint of determining soil properties, since it uses not segmental rods, but a coiled rod which can probe into the ground without stopping, it, I think, is superior to what we've been doing in the past with the standard cone penetration rigs.
This project was funded by the Priority Technologies Program of the Federal Highway Administration and LTRC. The outcome of this research has immediate practical applications in transportation systems and is envisioned to significantly advance transportation design, analysis, and construction practice.